Hello, my name is IQBAL AIMAN. So, for the introduction, numerous processes including image analysis, image filtering, picture reconstruction, and image compression require the Fourier transform. In a Gaussian blur, the pixels nearest the center of the kernel are given more weight than those far away from center. The Gaussian blur gets its name from the Gaussian function that determines how quickly this weight decreases. Lastly, Laplacian filters are derivative filters used to find areas of rapid change, edges, in image. Since derivative filters are very sensitive to noise, it is common to smooth the image.
Hello, my name is Muhammad Izzat. I'm going to present for task 1. So for the first thing is line 3 and line 4, which is set part for our picture. I'm using the image and I'm changing the title to original image. For the line 6, change to gray image by using RGB to gray data. So I'm set the title gray image. For the line number 9, I'm using Fourier transform of an image. And for line number 11, also the same, using Fourier transform of an image. For line number 13 and 14, I get the center spectrum. So the title is Center Fourier transform of image. Same also for line number 12. I'm using Fourier transform of an image for the title. For line number 17, I apply log transform. So I changing the title to log transform image. And the last is line number 19 to 22, which is I reconstruct the image. Then I'm changing the title to reconstruct image. For the output, the first image is original image. Second one is gray image. The third one is Fourier transform of an image. The fourth is center Fourier transform of image, and log transform image, and the last one is reconstruct image.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAZIM bin HUSIN. Will explain on task 2, which is applying a blur effect on our original image using Gaussian kernel. So the first line, which is I equal IM read, and then the image that we choose will read an image into the workspace, and then line 2 until 4 will filter the image with isotropic Gaussian smoothing kernels of increasing standard deviations. Gaussian filters are generally isotropic, that is, they have the same standard deviation along both dimensions. An image can be filtered by an isotropic Gaussian filter by specifying a scalar value for sigma. So line 5 until 7 will display the original image, and then line 8 until 16 will display all the filtered image, but as the value of sigma increase, so as the image will also become much smoother. So now I will run the coding and then show you. So this is the first image, and then the second image with the value sigma of 2, and then the third one is the smoothed image with the value sigma of 4, and then the last one is the smoothed image with the value sigma of 8.
Hi, Mama AZRIFF bin JOHARI. I do task 3 on this assignment. So this is all coding in the task 3. So we go through by line. First line, I equal to AMIR, and write the coding to include your display. So it will be gambar slash azrif.jpg. And second line, I'm sure is present to display the output. And third line, h equal to fs special, which is log 704. It means create a 7 by 7 log filter with a standard deviation of 0.4 using fs special. So for line I2 equal to I'm filter IH. I'm filter to apply the filter to the image using. And lastly, I'm show I2. So the I'm show I2 will be present the whole output. So the output will be like this. So this picture will be changed to the how the coding going.
For the conclusion, the Fourier transform is a representation of an image as sum of complex exponential of varying magnitudes, frequencies, and phases. The Fourier transform plays a critical role in a broad range of image processing applications, including enhancement, analysis, restoration, and compression. Gaussian kernel, as its name implies, has the shape of the function Gaussian distribution. To define the weights inside the kernel, which are used to compute the weighted average of neighboring points pixels in an image. The Laplacian filter is used to detect the edges in the images, but it has a disadvantage over the noisy images. It amplifies the noise in the image. Hence, first, we use a Gaussian filter on the noisy image to smoothen it, and then subsequently to use the Laplacian filter for edge detection.